Good evening, everyone. This lecture I'm going to record for term 7 of process engineering at Memorial University. So we are going to work on this workbook problems. We have 4 problems here. So I will have one video for heater and cooler problem, and I will make the second part of this video for the rest of the 2 problems in heat exchanger. So it is saying that a heater is required to increase the temperature of the methanol stream having a flow rate of 100 kg per hour from 25 at 100 kilopascal pressure to 55 degrees Celsius, and the pressure drop is 25 kilopascal using NRTL fluid package. Find what is the heat duty required. This is our first objective. The second objective is, if the heat duty is 25,000 kilojoule per hour, find the outlet temperature of methanol. So let's do this in HYSYS. As we can see that this is the methanol stream here. We go to our HYSYS and let me make some space here. We go to the new case study and we add our components. So click on add, and here you can search for methanol. Once you have methanol available, you can just double click this or click on add, and it will be added to your data bank. The next is we need to choose the fluid package. In our given problem, it is saying that our fluid package is NRTL. So how do you select the fluid package? You go to the fluid package on the left in the properties bar, click on add, and these are all the fluid packages available in HYSYS. So according to my problem, I need NRTL. So you just click it and it will be selected. As you can see that HYSYS has given me a green signal with the OK. This means the selected package is suitable for my component list. The next step is we go to the simulation environment. Now with this object palette, this is where my heater is. I will bring that into my simulation environment, and I will double click this. You can change the name of the heater if you like to change it. So for now I'm going to leave it as E100. Now let's define the stream as a first step. So let's say I give it a name inlet stream, and then I have the outlet stream here, and we need to provide the energy. So let's say I take it as Q here. The next step is to design a heater in HYSYS is to provide details of the stream. So we go to our worksheet and then we go to our problem here. Let me close this. We go to our problem here, and it is saying that the temperature of the methanol is increased having a flow rate of 100 kilogram mole per hour. So the inlet stream has the flow rate of 100 kilogram mole per hour. If your HYSYS is on active mode, it will automatically take the same flow rate for the outlet, because heater is not going to change any flow rate. It is not a pump. This stream is at 25 degrees Celsius. You hit 25, press enter, and its pressure is 100 kilopascal. This is my 100 kilopascal. If you have different units, you can choose them. For now it is 100 kilopascal. And the outlet stream pressure is 55. I press 55 and I enter 55, and now my temperature is showing me in different units. I will take my Celsius here. Now I have not been provided with the pressure of the outlet stream, but I am given the pressure drop in the stream. So I go to my design here, go to the parameters, and this is where you need to add your drop in pressure, which is 25 kilopascal. Once you have entered your parameters, the last thing which is missing is the composition. You need to go to the composition and hit enter 1 here and press enter. It will pop up a window. Because it's only one component, so your mole ratio should be 1. It is OK, and as you can see that I have a green signal from HYSYS here, which is indicating that my heater has been simulated. So I will close this window and I will show you this one. So this is my inlet steam, outlet steam. This is the amount of the energy I'm providing to this. Now you want to analyze the results. You go to the design tab and the parameters. So according to our first requirement, it was asking what is the heat duty required. So the heat duty required is 351,242 kilojoule per hour. That's what is your answer for the first part. Now in the second part, it was asking us if the heat duty is 25,000 kilojoule per hour, find the outlet temperature of methanol. Now for that one, you need to enter the duty here. However, if you will enter duty in the current situation where you already have defined the outlet temperature, it will give you an error. So what you need to do, you go to the worksheet and delete your outlet temperature. I just hit it and press delete on your keyboard and press enter. As you can see now, I have unknown duty. So the duty which has been gone, which was calculated previously, now the new value is for part B is 25,000 kilojoule per hour. The units are already selected, and once I hit enter, you can see that the simulation has been done. So for the part B, it was asking find out the outlet temperature of the methanol. So you go to the worksheet here. Now this temperature has been calculated by HYSYS. So your answer for the second part is 27.16 degrees Celsius. That's what is your answer for the second part. As you can see, there is a very slight increase in the temperature, so we should definitely increase the heat duty of our heater. So this was how you simulate your heater. Now the next problem is based on the cooler. It is saying that the cooler is required to decrease the temperature of the methanol stream having the flow rate of 100 kg per hour from 55 degrees Celsius at 100 kilopascal pressure to 25 degrees Celsius, and the pressure drop is 25 kilopascal using the NRTL fluid package. Find what is the heat duty required, and if the heat duty is 25,000 kJ per hour, find the outlet temperature of methanol. The designing of a heater and cooler is the same. There is no difference. The only difference is that you need to choose a different equipment. So I'm going to do the same. I'm going to use the same simulation file because if you look here in my cooler example, I have the methanol system which is already there in the heater example, and I'm supposed to use NRTL fluid package which was already selected in heater problem. So what we need to do, we will bring in our object palette here. This is my object palette, and this is the symbol that we have for the cooler. So you bring this cooler into your simulation environment, and then you double click this. Again, you can change its name if you like. So let me close this now. And now I need to provide the inlet stream. So let's say I provide inlet stream. I will give it a name of number 1 because I have already that stream defined from the heater example. So just to differentiate it, so this is outlet stream 2, and let's say it is giving me the energy of E. In the next step, we need to go to the worksheet, and here we need to enter the properties of our streams here. So let me bring this here. So my inlet for my inlet stream, my temperature is 55. That's what I'm looking to decrease up to the temperature of 25 degrees Celsius, and the pressure of the inlet stream is 100 kilopascal. I don't have the pressure for the outlet stream, but I do have the pressure drop here. So I go to the design tab, click on the parameters, and here I will enter my drop in pressure, which is 25 kilopascal. And next you need to add the composition here, because I only have one component, so this will be one here. Okay, so we have entered our composition here, we have entered our delta P here, and we have entered our conditions here. Now we need to add the molar flow here, which is 100 kilogram mole per hour. And now the HYSYS has converged my cooler here. I can take you to the HYSYS window here. Now that's what is my cooler defined here, that it is taking out the heat from the stream. The heater is something which is taking in energy into the stream. So we can analyze it now. Based on the first question, it was required, what is the heat duty required? So you go to the parameter, and this is what is the value of your heat duty for the cooler. The second objective is, if the heat duty is 25,000 kilojoule per hour, what is the outlet temperature? So you can go to your worksheet, delete the outlet temperature, because that's what you want to want to find out. And now you specify your value of the heat duty here, which is 25,000 kilojoule per hour. As you can see, now it has converged my cooler. And you go to your worksheet, and this is my outlet temperature of the stream. There's a very slight decrease with this heat duty in the cooler as well. It is decreasing from 55 degrees Celsius to 52.89, which is approximately 53 degrees Celsius. So that's all about these two problems. Now I will make part 2 of the videos, where I will do next two problems on the heat exchanger. Dynamics part, when we will go to the dynamics analysis, I will show you how we work in this environment. Now before I leave, I just want to show you how you can change this icon. So you just right click here, you go to your icon, and you can choose any shape here. Mostly in the process flow diagrams you will see heater something like this. Similarly, you can right click on cooler, and you can change its icon based on your flow sheet. So that's all for this video. I will see you in the part 2, where I will work on these two problems. Thank you.